Okay, so particle solution, this is section 15.4 in your textbook. First thing we're going to start off is talking about the nature of solvents and solutes and how they kind of interact with each other. Question is, why do vinegar and oil not mix? Any ideas? One is polar. Why do vinegar and oil not mix? Possibly one is an ionic. Okay, possibly one is polar, one is an ionic. Other ideas? Nobody thinks there are fairies in one and gremlins in the other, and they don't mix? No. All right. Next question. Why will a solute dissolve in one solvent but not another? One can hold more than the other? Depends on which one you have more of. So it depends on which one you put more in. In both cases, they can be either a solute or a solvent. What you do to it? Okay, give me an example of what you mean. Okay, if you increase the temperature, decrease the temperature, that will affect whether it will dissolve or not, you're saying? Okay. Okay, so you're saying water has a positive and a negative, and vinegar does not. Okay. All right, that's a good idea. Let's look at some of these ideas and see if we can figure out what's going on. We're not going to answer the question. They are to get you thinking about the topic that we're going to face. So, the nature of solvents and solutes. The answer to the question previously, why do oil and vinegar not mix, is related to polarity. Okay, polar substances dissolve polar and ionic substances. Okay, non-polar solvents dissolve non-polar solvents, solutes. The polar substances dissolve non-polar solvents dissolve. If you look on the right, is that diagram on the right, you'll see that we have these water molecules. There's a little bit of, you see this positive here at the top, there's a negative down at the bottom. They have two ends, one that's positive, one that's negative, like Eric was saying. And so this, going back to kind of the stuff we studied before, polar means the electrons are not evenly spread. They are in some situations, some locations more than others. Okay. The general rule is like dissolves like. Yeah. Like itself. Yes. So like dissolves like. If the things are too different, they will not dissolve each other. Ready to move on? All right, next page. There are some exceptions to this. You look at this molecule here on the right. This is a molecule of ethanol. Okay, it has some carbons in it. It has some hydrogens attached to those carbons. It has an oxygen and a hydrogen at the right-hand side. So, some substances are both polar, like this OH, and non-polar, like the end of the molecule that has CH3. Some substances are both polar and non-polar. All right, they form solutions with both polar and non-polar solutes. So we said like dissolves like, except when it has both. If it has both polar and non-polar as part of the molecule, it will dissolve both kinds, both polar and non-polar solutes. Ready to move on? example is ethanol. It has both kinds. It has polar on one end, it has non-polar on the other end, so it will dissolve both kinds of substances. All right, ready? Next. There. She does. What is she holding in her hand? She is a hair blow dryer, right? So, why should you not use a hair dryer? Electricity goes through water like tap water. Tap water is a good conductor of electricity. And so it will conduct electricity through you and it will hurt you.
Why should you not use a hair dryer while standing on a wet floor? You can't stand on a wet floor.
Not a good idea. Because one day I was, when I was in Africa, I was at my house working on doing my laundry. And I turned the water on and it was weird. The washing room, or the laundry room. And it was like I touched the handle and my hand tingled. It was really strange. Touched the handle and like something's happening. Very strange. My hand was tingling when I grabbed the handle. Later on, I came back out to rinse my clothes because we didn't actually have a proper machine. And I came back out in my stocking feet, and I was standing in the puddle of water that kind of had spread itself all over the place. And I reached out to grab the handle, and I couldn't turn it. Like I grabbed a hold of the handle, and I tried to turn it, and my hand wouldn't work. It had the same buzzing feeling. It was stronger though. And I figured out eventually, after several tries, that what had happened was that there was the water heater had broken, and so it was electrifying all of my water. So the faucet was filled with electricity and was basically running through my hand, and that's why my hand wasn't working. It was shorting all my muscles and none of them could work. It was close to being very dangerous. I was very lucky that it didn't.
I don't remember that.
Yep. So, next question. Why can lightning kill you? Kill you?
It's strong.
Because it's strong. Derek? Right. It depends how much charge there is. It depends. We have to talk about exact numbers. I don't actually have a good number for that, so I have to look it up. It can. So, the reason it kills you, the reason lightning can kill you, or dropping the curling iron in the tub will kill you, is that you have dissolved ionic compounds in your blood. Your blood is a good conductor. And so what happens is blood and hit your heart and stop your heart, which also runs on electricity, turns out. So the reason it goes through you so easily is that you have dissolved ionic compounds in solution. There's a term for this. It's called, yes, electrocution. Electricity, right? There's electrocution. Another term that we need to know about that's related to this is electrolyte. Jimmy, I am lecturing. Please don't. All right. So, Correct. Why? Yes, well, here's the problem. You would do all 3 strikes every day until you got out one day, and I'm not okay with that. We need to actually keep things handled the way they are. We can talk about it after class. Not right now. So, solids and water solutions. There are 2 kinds. Electrolytes, which are substances that separate into ions or form ions. Those are electrolytes. Notice electrocution, electrolyte.
Never mind.
Electrolytes. Substances separate into ions or form ions in a water solution.
Wait.
I'm still on that page. Example is sodium chloride, salt, and sugar. Salt will break down into species. An electrolyte is a substance that makes water able to conduct electricity. Yes.
For water.
No, in this case, you need to actually force the ions back in the direction. What happens in batteries? The electrons move one direction until they're all piled up to the far side. And what you need to do to charge your batteries, you push them back the other way so that they can slow down. All right. So electrolytes are substances that you add to water to make it able to conduct electricity. No.
Why not?
Just sugar and water. That's not going to solve your problem. So, non-electrolytes are electrolytes that do not conduct electricity. An example of that is pure water. If it's pure water, it won't conduct electricity. However, if you have water that has lots of ions on it, such as the ocean, you don't want to be in it when there's electricity around. Which is part of the reason why they chase you out of the ocean when a thunderstorm shows up, even if it's several miles off the coast. More than just a little. It could kill you and then you'll drown because you're stunned.
It would kill me because that drown. It'll kill you and then you'll drown.
Either that or it'll stun you and then you'll drown. All right.
So many possibilities.
Many ways to die. All right, so since you seem to be done with this slide, let's move on to the next one. Write faster, people. Once you're done, if you're talking, I take it to mean that you're done. Non-electrolytes, examples, pure water. I have. Oh, yes, deionized water. Actually, that container over there, that's pure water. It's distilled water.
What's the difference between pure water and...
Non-pure water has ions in it. Pure water has no ions in it. Just water.
So most bottled water is pure?
No, most bottled water is actually is not pure water. It's water with some calcium. Pure water. All right.
What about tap water?
So, once again, solids in water solution, things that are electrolytes. A solution that has an electrolyte in it will have an ionic substance or a polar substance. Okay? A solution that does not, well, if it is a non-electrolyte, it is a non-polar substance. Those are things that you can add. Now, once again, just to clarify, ionic versus polar. Okay? Ionic is a metal. It's a substance that is a metal with a non-metal. Where is a metal on our periodic table? The left. So this area. These metals or non-metals? Right. Non-metal plus a metal. Okay. They are made of ions. And examples are MgCl, magnesium chloride, FeOH2, iron hydroxide. Those are examples. Okay. Polar substances. They are only nonmetals. So just stuff from the right-hand side of the periodic table. They're made of atoms. And some examples are SO2, or HCN, or H2O. All right. Do you need to make an announcement again? Okay, sure. That'll work. All right. Next slide. How much more do you have, Ethan? 3 words. All right. So we talked about ionic polar. All right. Ionic solids in water solution. Copy off of Kimmy. Question: what happens when an ionic solid dissolves in a solution? That's the question we're going to talk about next.
Positive and negative ions.
Positive and negative ions do what?
Separate.
They separate. The positive and negative ions separate. What is the name for that? It is called dissociation. The process of positive and negative ions separating. And example is, if we take salt, sodium chloride, we put it in water, we get sodium Na+, and minus. All right. You're going to try. I don't think we're going to succeed. All right, so ion separate dissociation. Everybody done with this slide? Okay, so what I want you to do on the left, what this looks like, I'll show you the pieces I want you to use. I want you to use the following, here are the following molecules you need to use. If I can find my pen. You need to have, this is an ionic solid, NaCl, okay? You can use that. You can also use Na plus and Cl minus, that's an option. You can also use H2O. You need to draw here in this left box how you think these are, how you think this would look. Example being, you draw a box and you draw your NaCls and Na pluses and Cl minuses where you think they might be in this box. Okay. All right. So do your best guess. Write your drawing. Draw how you think it is on the left. I will tell you that
You draw bubbles?
you can do a bubble. You do a symbol for each one. You can draw on the box. Draw what you think it will look like. 100 milliliters? Sure. I don't know. As big as the lines. We're gonna act like we can zoom in really close so we can actually see these particles. Usually we can't because they're tiny. I want to actually see you draw the particles themselves. At least some of them. All right, I'll give you 30 seconds. All right, so here's the correct answer. I'm going to draw a line on here. That's the top of the water. Okay. The way that this ends up looking is you have H2O scattered around throughout. Well, there are no fish in the solution. The water molecules are everywhere. You also find that the Na pluses are spread out evenly throughout. Because our NaCl became Na plus and Cl minus. So Na pluses are evenly spread throughout. You also have the Cl minuses evenly spread throughout. These are the three that will be here. Okay, so that's how your drawing should look. Cl minuses spread evenly, Na pluses spread evenly, H2O spread evenly. All right. Yep.
I'm just really hungry.
I know. So is everybody else, and they're very distracted. It's okay. All right.
I'm really hungry.
Next, the specific locations of the molecules are not as important as the general idea, Lindsay. All right, next slide. Polar solids in water solution. So, when polar substances dissolve in H2O, ions form, and the process is called ionization. Okay, so when polar substances dissolve in H2O, ions form, process is called ionization. Example is C12H22O11. That's sugar, by the way. C12H22O11 is sugar. Plus H2O goes to sugar as an ion. Careful. Use the wall if you need to. Yes, use the wall if you need to. Okay? The plus means it's an ion. AQ means it's aqueous or mixed in water. Okay? So go to your next page and draw your picture on the left, what you think it's going to look like. The pieces you will need are C12H22O11 and H2O. And possibly, if you wanted it, carbons, hydrogens, and oxygens separate. Or actually just do those two. So you have three options for things to draw. Tommy, what are my three options? What? Then don't talk. You can hear me better. C12H22O11 is one of your options to draw on the diagram. H2O is another one. You can also write carbons, hydrogens, and oxygens independently if you would like. So your guess goes to the left. I'm going to give you 30 seconds to draw your diagram on the left. Correct answer is as follows. You have C12H22O11, H2O, and CH and O. The way this ends up looking is the following. H2O is once again spread throughout. All right. H2O is still spread throughout. And your C12H22 is also spread out as it is. That is what it looks like. Ready to move on to the next slide?
Yep.
All right. The effects of having solute particles present. It lowers the freezing point. Okay? By disrupting the formation of ice crystals. Now, what's the freezing point of water? Anybody know? 32 degrees Fahrenheit, or 0 degrees Celsius. So, what would the freezing point then be if we lowered it? Lower than that, like 30 degrees C, or sorry, 30 degrees Fahrenheit, or negative 2 degrees Celsius. So it could lower the freezing point, make it harder to freeze. An example of this is antifreeze. The stuff we put in the radiators of our car. We really don't want ice blocks in our radiators. It does not work well. It will break things. All right. I will see you guys later. I hope so. No quiz tomorrow. The quiz, by the way, ladies and gentlemen, attention up here real quick. The quiz for this section of material will be on Tuesday of next week. Wait. Wednesday of next week. Wednesday of next week is when the quiz over this material will be. Once again, quiz over this material will be Wednesday of next week. I will remind you on Tuesday. Yes, that's the plan. I can do.